And you're going to need some type of ruler for this. And first I want to go over some of the basics. A dilation, first off, is not isometric. Which means we're going to change the size of whatever object we're dealing with. So this is about either enlarging or shrinking. I couldn't come up with a better word than shrinking for that, but now, for this one, you need a figure of some kind. And a point of dilation. And a scale factor. The nice thing is we don't have to worry about angles, we don't have to worry about anything like that. What we're going to do is we're going to just need a ruler of some kind. So, here's an example. I'm just going to draw a triangle here. Alright, so here's our figure. A, B, C. Alright, and now you have your point of dilation. And let's say we want a scale factor of 1.5. Let me move this up here. Alright, so alright, the first thing that we're going to do, and I'm going to move this over here so we can kind of see it a little bit better. We're going to draw lines through point D, or from point D through A, B, and C. So we end up drawing these lines like this. And if you really wanted to, at the end of the lines, you could put some points like this, just to make sure that you know which line is which, because sometimes the lines get really close to each other, so it's always good to know exactly which ones you're looking for. second thing you want to do, you want to measure DA, DB, and DC. So we need to get some type of a measurement with each one of those. And DA looks to be 3.1. And I'm going with centimeters here. So I'm using centimeters just because it's a little bit easier to deal with. Now with B, looks like about 5.2, so DB is 5.2. And then DC looks to be about 3.6. So I got 3.1, that one was 5.2, and this was 3.6. Now what we want to do is, because our scale factor is 1.5, I want to multiply this by 1.5, multiply this by 1.5, and multiply this by 1.5, and get the answers for this, because this is going to get me to DA prime. The second one is going to be to DB prime, and the third one is going to get me to DC prime. So basically what we're saying is, this is 3.1, my scale factor is 1.5, so I need to figure out what 1.5 of 3.1 is. So it's going to end up being up here somewhere. So you take your calculator, .1 times 1.5 is 4.65. Then we go 5.2 times 1.5, 7.8. 3.6 times 1.5, 5.4. And these are still all in centimeters. So make sure that you keep everything in centimeters here. Alright, so we were able to calculate all of those. So 3 multiply all the measures by the scale factor. And now that we have the new distance, plot A prime, B prime, and C prime. So A prime is going to be 4.65 away from D. So we're going to remember we're still in centimeters here. So there's D. I want 4.65. That was about 4.65. D is 5.2, so I need to go to 7.8. So there's the 0, 7.8. there's B prime, and C prime was 3.6, or C was 3.6, so I have to go to 5.4. Which is C prime right here. And now I'll use a different color to be fancy. Thank you, sir. And we get a new shape. Kind of came out a little bit weird. It should look almost exactly like this. I'm not sure exactly what happened with that. But this is what we call an enlargement. If we would have ended up here, it would have been what we call a reduction. Now, does that make sense how we figured this out? It's step by step. Figure out the lengths, then we're going to multiply by our scale factor, we're going to find our new points, then we're going to draw it, and then we're going to be done. Just make sure you draw the lines through like this. Yes? Yeah. I just randomly put it there. Wherever you want to. A lot of times they'll give you D and they'll give you a shape and they'll say, here's your scale factor. And then you just have to draw the lines, measure them, multiply by the scale factor, and find the new points. Now, one last thing before I get you started on your work. Scale factors. Now, if it's greater than 1, it's an enlargement. If it's less than -1, it's an enlargement in the other way. Meaning that I could have drawn these lines out like this. The negative scale factor would have put it on the other side of the point of reflection, or the point of dilation. Here, between 0 and 1, is a reduction in the other way. Over here is a reduction. So think of a scale factor. Here means it's 100%. A scale factor of 1 means that you want 100% of the shape. If I said use a scale factor of 1 with triangle ABC, you'd end up drawing the exact same triangle right on top of it. You wouldn't change its shape or anything. If you think about a photocopy machine, that would just be putting a photocopy, or putting a piece of paper in the photocopy machine and taking a copy of it and getting the exact same sheet back. But we can enlarge things and we can reduce things in a photocopy machine. This is the same idea. This is like the geometric version of a photocopy machine. If I want an enlargement, if I want to make something, if I want to make this triangle bigger, then I'm going to use a scale factor that's bigger than 1. And so this would be an enlargement because this was a scale factor of 1.5. If it was less than, this is this area right here, your scale factor is less than 1. If it's negative, it's just going to end up on the other side. Does that make sense?